Hello friends, I am Snehal and I am teaching you physics. In today's lecture, we'll see the mathematics required for study of motion in 2 and 3 dimensions. So let us start. There are two types of physical quantities: scalar quantities and vector quantities. The quantities which have only magnitude and no direction are called as scalar quantities. Vectors are physical quantities which have magnitude as well as direction. So these are quantities which have magnitude only. Vectors have magnitude and direction. What are examples of scalar quantities? So mass is scalar quantity, time is scalar, energy is scalar, and there are plenty of them. Examples are mass, energy, temperature, and examples of vector quantities are displacement, then velocity, acceleration, force. A vector is represented by an arrow in space like this, and the tip of arrow, it shows the direction of vector, while the length of arrow represents magnitude of vector. So the length represents magnitude. Suppose I want to denote velocity by vector notation, then how do I denote it? So I write v and I put this arrow on top of v to show that it's a vector quantity. Now let us see some definitions related to vectors. So suppose we are given with some vector, what will be negative vector? So suppose we have this vector called a bar. The negative of this vector will be a vector having same magnitude and opposite direction. It's obvious. So this will be minus a bar. Then next is null vector or a zero vector. So this is a vector having no magnitude. For example, suppose I have this a bar and I add minus a bar to it. So a minus a should give me 0. But left hand side of this equation is vector. So right hand side should not be a scalar. So for that we put this arrow on this top of the 0 and we call it zero vector or null vector. Then what is property of the null vector is that if I add this null vector or zero vector to some other vector, I will get back the same vector. So a bar plus this o bar is equal to a bar. So addition by this vector will not change the magnitude. The next we'll see is unit vector. So a vector which has magnitude of 1 unit in a specific direction, it is called as unit vector. So suppose this is our a bar and suppose its magnitude is 5 units. 1, 2, 3, 4, 5. So a bar has magnitude of 5 units. So how do we denote magnitude is that we put this mod sign, and the mod of A will give me magnitude of A, which is 5 units. Now unit vector in direction of A bar will have this much magnitude equal to 1. So this is a unit vector in direction of A bar, and I denote it by this sign, A cap or A hat. So this is a unit vector. Now given A bar, what will be half of A bar? So it will be a vector having magnitude equal to half of A bar. So this is half A bar. If I multiply this half A bar by 2, that means if I take half A bar and half A bar, I add them, then I will get this A bar. So similarly, if I take this unit vector and multiply it 5 times, I will get back this A bar. So A bar is equal to, I can say, 5 times this A cap, in this case, this particular case, and 5 is the magnitude of A bar. So I can write A bar is equal to magnitude of A bar multiplied by A cap, or A cap is equal to A bar divided by its magnitude. Now many a times we will denote this magnitude like this only. So if A bar is a vector, then A without that arrow will be magnitude of A bar. Okay, so these are some definitions related to vectors. Now let us see how vectors are added. Let's see addition of vectors. So suppose we have this person, and this person starts from this point, let's call it O. He goes to this point, let's call it P. So this OP or OP bar, it is displacement vector for that person. It's partial displacement vector. Then from this point he moves to some other point, let's say Q. So this OP bar, let me call it A bar, and OQ bar, let me call it B bar. They are partial displacements of that person. What will be complete displacement? So we know that displacement is shortest distance between the start point and end point of motion. So it better be this OQ bar. This thing is the total displacement. But these are partial displacements. This is partial displacement. So sum of these partial displacements A bar and B bar gives me this total displacement C bar equal to A bar plus B bar, and that's why now I have law to add vectors. So this law is called as tip to tail, or this is called as triangle law. So what does it say is that if two vectors are represented by two sides of triangle taken in order, so taken in order means where first vector ends, the second vector starts at that point, then the resultant is represented by the third side of triangle starting at the start point of first vector and ending at end point of the second vector. This is triangle law. Now suppose I want to subtract B bar from A bar. What should I do? So we know that subtraction is also addition. So suppose this is A bar So I want to perform this operation a bar minus b bar, which is equal to a bar plus minus b bar. So I will take this b bar, rotate it by 180 degrees. So this is b bar rotated by 180 degrees. So this is minus b bar, and now a bar plus this minus b bar, it will give me the resultant of this operation. So which will be this one. So this vector is a bar minus b bar. Okay, so now let's see some properties of this vector addition. First property is that this addition is commutative. And what does commutative mean? So a bar plus b bar equals to b bar plus a bar. This is commutative. How to prove this? Suppose I have this a bar, then I add this b bar to it. I get the resultant by this triangle law, that the resultant starts at start point of first vector, ends at end point of second vector. So this is the resultant, c bar, which is equal to a bar plus b bar. Instead of doing this, what I can do is, first I will take b bar and then I will add a bar to it. So let's take b bar at this point. So this is my b bar. Now I will take this a bar and put at the end point of b bar, or tip of b bar. Sorry. So I put this a bar here, and look, what do I get by b bar plus a bar? So I get same vector, c bar. So it means that this thing proves the commutative rule for addition. The next rule is the associative law. And it says that a bar plus b bar plus c bar is equal to b bar plus c bar plus a bar. So if I take a bar and b bar, I add them, then I add c bar to this addition of a bar and b bar, or resultant of a bar and b bar. It is same as the addition of b bar plus c bar and then adding a bar to that addition or that resultant. Let's prove that. So let's take a bar. So this is my a bar. This is some b bar. And what will be the resultant of a bar plus b bar? We know by triangle law that this will be resultant of a bar plus b bar. So this is a bar plus b bar. Then let's take c bar somewhere. So suppose this is my c bar or c arrow. Now the resultant of a bar plus b bar and c bar will be this one. So a bar plus b bar is this vector and c bar is this vector. So the resultant will be this one. Okay, let's call it d bar. And this d bar is equal to a bar plus b bar plus c bar. Okay. Then, now what we have to do is, we have to add b bar and c bar. So let's add b bar and c bar. So resultant of these two will be this thing, this vector. This will be b bar plus c bar. Now I want to add a bar in that b bar plus c bar. So it is same as that of adding b bar plus c bar to this a bar by this commutative rule, because a bar plus b bar is equal to b bar plus a bar. So this is same as a bar plus b bar plus c bar. So a bar plus b bar plus c bar, you can see that it gives me this same vector d bar. So this thing proves this associative law. Okay, now let's see resolution of vectors, which will simplify the process of addition. So resolution of vectors. Suppose we have this a bar and b bar, and c bar is resultant of addition of a bar and b bar. So c bar equals to a bar plus b bar. Now if we write a vector as addition of two or more vectors, then that vector is said to be resolved in these vectors, and the vectors in that sum are called as components of this vector. Now we are interested in a particular case of resolution, and that is called as resolution in rectangular components. Rectangular means perpendicular. So let's see resolution of vectors in perpendicular or rectangular components. So this is my y-axis and this is x-axis, and suppose I have this vector r bar. I will draw perpendiculars from this point, and I will call this vector rx bar and this vector ry bar. Now it is clear that this r bar is equal to rx bar plus ry bar, because I can show that ry bar here also. So rx bar plus ry bar is this r bar. So now this r bar is resolved in these components which are perpendicular to each other. So they are called as rectangular components. So suppose this angle is theta. Now we know that suppose we have a vector r bar, we can write that vector as the magnitude of vector multiplied by unit vector in that direction. So similarly, I can write this rx bar and ry bar as magnitude times the unit vector in that direction. Now unit vector along x-axis is called as I cap, and we call unit vector along y-axis to be j cap. So I can write r bar is equal to this rx, the magnitude, multiplied by unit vector, which I will call I cap, and here ry multiplied by the unit vector, which I will call j cap. Now let's find this rx and ry. So from here I can write cos of theta equals to this side. So length of this side is magnitude of rx bar, rx, divided by hypotenuse. So it is rx divided by r, and similarly sine of theta is this ry divided by r. So sine theta equals to ry divided by r, and therefore rx is equal to r multiplied by cos of theta and this ry is r into sine theta. So we can substitute it here. So I can write r bar is equal to r cos theta multiplied by I cap plus r sine theta multiplied by j cap. Okay, now we can just divide this equation by this equation, and doing that we'll get tan theta equals to ry divided by rx. Okay, so here tan of theta is this opposite side upon hypotenuse side, so it is ry divided by rx, and theta gives me the direction of r bar with respect to this x-axis. So it gives me direction of the resultant of rx bar and ry bar with respect to the x-axis. Then what is magnitude of r bar? So it is very clear from Pythagoras theorem. I can say rx square plus ry square is r square. So r square is equal to rx square plus ry square by Pythagoras. And therefore r is equal to square root of rx square plus ry square. Now this is how we resolve a particular vector in rectangular components. So this is resolution. Then we write the magnitude of that vector in terms of these components. So r is equal to square root of rx square plus ry square. And then we find angle made by the vector with x-axis. So tan of theta is ry upon rx. So theta is tan inverse of ry divided by rx. Now this is for the case of 2D. Let's see for case of 3D. We can just generalize this. So for 3D, this is my z-axis, this is y, and this is x-axis. And suppose this is the vector to be resolved. R bar. Now let's draw a perpendicular from this tip of R bar on this xy plane. So suppose it meets here. Then draw a perpendicular from here. So these are perpendiculars. Then let's join this. So this angle is 90 degree, this angle is 90 degrees because it's a perpendicular, and this angle is 90 degree. Okay, now I will call this vector Rx bar. This vector is Ry bar. And this vector from here is Rz bar. Now it should be clear that this R bar is equal to Rx bar plus Ry bar plus Rz bar. See how? Suppose this is C bar, this vector here. So I can say that C bar is equal to Rx bar plus Ry bar. And Rx and Ry are perpendicular to each other. That's why I can write C square is equal to Rx square plus Ry square. Then see here, so I can say C bar plus this vector, which is equal to this vector Rz. So C bar plus this Rz is equal to R bar by triangle law. So C bar plus rz bar is equal to r bar. And this was perpendicular, so this angle is 90 degrees, so C bar and RZ bar are rectangular components of R bar. So I can say R square is equal to C square plus RZ square, and C square is Rx square plus Ry square. So I have R square is equal to C square plus, this Rx square plus Ry square plus Rz square. And therefore R is equal to square root of Rx square plus Ry square plus Rz square. This is the magnitude. And R bar is C bar plus Rz, that is Rx bar plus Ry bar plus Rz bar. So let me write it here. R bar is equal to Rx bar plus Ry bar plus Rz bar. And just similar to the last case, 2D case, I will write this as Rx into I cap plus Ry into j cap, and unit vector in direction of z axis is called as k, so plus Rz times k cap. This is R bar. So this is how we resolve vectors in the rectangular components. Okay, so suppose we have the C bar equals to A bar plus B bar. Now I will represent every vector by its component. So let's take 2D case only. So this is Cx times I cap plus Cy times j cap. This is equal to Ax into I cap plus Ay into j cap. And for B bar, Bx into I cap plus By times j cap. Now let's take I cap and j cap common from right hand side. So we get Ax from here and Bx from there. So Ax plus Bx into I cap plus Ay plus By times j cap. Now the equality of LHS and RHS demands that the coefficients of I cap and j cap on both sides of the equation should be equal. So it means that Cx should be equal to Ax plus Bx and Cy should be equal to Ay plus By. So this is how this resolution of vectors method makes addition of two vectors an algebraic sum of components. Now let us see derivation for the resultant of triangle law of vectors addition. So derivation for resultant of addition of two vectors. Now suppose we have this A bar and this is B bar. Then by triangle law, we know that resultant is this one, starts at starting point of first vector, ends at end point or tip of second vector. Now I can draw this B bar here. So we know that this addition is commutative. So this is my B bar. And let's draw this A bar like this. This is A bar. Now this is a parallelogram. So the triangle law can be equally called as parallelogram law. This is resultant. So suppose we have two vectors A bar and B bar represented by two sides, two adjacent sides of a parallelogram, and they start at the same point, then the resultant is represented by this diagonal of parallelogram, which also starts at the same point as that of starting point of two vectors. Now this can be called as parallelogram law. So we have to find the magnitude of resultant, given the magnitudes of A and B and angle between A and B. So suppose angle between A and B is theta. So let's name this. Let's call this O, E, F, G. Now how do we proceed? So we use this trick. We extend this line and draw perpendicular from here. Suppose it meets at this point. Let's call it M. This is B bar. Okay, now this angle is theta. So this angle should be also theta. It's because these are parallel lines and this is an intercept. Okay, so let's take this triangle. So I can say in triangle OFM by Pythagoras theorem. So by Pythagoras, OF square hypotenuse square is equal to sum of squares of these perpendicular sides. So OM square plus FM square. Now magnitude of A bar is this OE and magnitude of B bar is EF. So we'll introduce it. Now I can write this OM as OE plus EM. So this is OE plus EM squared plus FM squared. And now let's just expand this. So we get OE square plus 2 times OE into EM plus EM square plus this FM square. Okay. Now see, this EM square plus FM square is this EM square and FM square will give me this EF square by Pythagoras theorem. So by Pythagoras theorem, this is EF square. So let us write OE square plus 2 times OE into EM plus this EF square. This is OF square. Okay, now OF is magnitude of R bar. So let's substitute that. This is magnitude of OE is magnitude of A bar. EF is magnitude of B bar. So this is R square equals to A square plus OE is magnitude of A. So 2 times A into this EM plus EF square, which is B square. Then we have to find EM in terms of A or B. So we can see here that in this triangle, so cos of theta is EM divided by EF. Adjacent side divided by hypotenuse. So this EF is magnitude of B. So this is EM divided by B. And therefore I can write EM equals to B cos theta. Let's substitute it here. So we get R square equals to A square plus 2AB cos theta, EM is B cos theta plus B square. And therefore taking square root of that, we'll get magnitude of R bar. So R equals to square root of A square plus B square plus 2AB cosine of theta. This is very, very important relation. Then we have to find the direction of R bar. So let's find it. Suppose it makes an angle of alpha with this A bar, the first vector. So what will be tan of alpha? So in this triangle OFM, I can write tan of alpha equals to this FM divided by OM. Then OM can be written as OE plus EM. So this is FM divided by OE plus EM. Now we have found that this EM is B cos theta, and similarly this FM will be B sin theta. So sin theta is FM divided by B. Therefore, this FM will be equal to B sin theta. So let us substitute that here. So substituting that, we get tan of alpha equals to FM is B sin theta divided by OE, which is A, plus EM, which is B cos theta. So alpha will be tan inverse of this right hand side, B sin theta divided by A plus B cos of theta. Okay, so we found the magnitude and direction of the resultant. It is inclined at an angle alpha with the first vector. And how do we find that angle alpha? It is that the magnitude of second vector, angle is made with first vector, we take tan of that angle is equal to magnitude of second vector multiplied by sine of the angle between two vectors divided by magnitude of first vector plus magnitude of second vector into the cos of angle between the two vectors. So this is how we find magnitude and direction. Now there is another rule to find the direction or the angle alpha made by this resultant with the first vector. So let us see that. I will erase this. And what we do is we take sine of this alpha. So let's find sine of alpha. I can write it is equal to this opposite side is FM divided by the hypotenuse. Hypotenuse is OF, or I can say it is R. So FM equals to R into sine alpha. This is first equation. Okay. Then we can take in this triangle the sine of theta. So in this triangle EFM, sine of theta is equal to FM divided by the hypotenuse, and hypotenuse is magnitude of B bar, which is B. So it gives me FM is equal to B sin theta. This is 2. So from 1 and 2, I can write R sin alpha should be equal to B sin theta because left hand side is equal. So R sin alpha equals to B times sin theta, and let us write this as R divided by sin theta equals to B divided by sin alpha, and let us call this equation number 3. Okay, then what we do is that we draw perpendicular from here. So like this, suppose this is some point, let's call it N. Let us erase this. Now you can see that in this diagram I will find sine of alpha, and let's say angle between B bar and the resultant is beta. So this is the angle. So what will be sine of alpha? it is equal to En divided by this hypotenuse, and hypotenuse is magnitude of A bar. So it is En divided by magnitude of A bar, which is A. So it gives me En equals to A sine alpha. Then similarly, we can take sine of this beta here. So sine of beta will give me En divided by this hypotenuse. So sine of beta gives En divided by the hypotenuse, which is magnitude of B. Okay, and then I can write this as En equals to B sine beta. So let's call this 4, this 5, and from 4 and 5. What can I write? Left hand side is equal, so right hand sides should be equal. So A sine alpha should be equal to B sine beta, just like the previous case. And then A divided by sine beta, rearranging this, we get B divided by sine alpha. So let's call this equation number 6. Okay. Then from 3 and 6, you can see that the right hand side is equal. So let us write this relation: A divided by sine beta equals to B divided by sine of alpha, and that is equal to this R divided by sine of theta. So R divided by sine theta. This is from 3 and 6. And this thing is called as sine rule. Okay, and this is very simple compared to that previous relation for angle alpha, so which was tan of alpha equals to B sine theta divided by A plus B cos theta. So this is simpler. How to memorize this? So we have this vector A bar and B bar, the resultant is R bar. So pick any vector of these three. So suppose I pick A bar. So magnitude of A divided by sine of angle between remaining two. This is beta. See, beta is angle between B bar and R bar. So magnitude of A divided by sine of angle between remaining two. It is equal to magnitude of B divided by sine of the angle between remaining two. And it is equal to R bar divided by magnitude of R bar divided by sine of the angle between remaining two vectors. So this is how we'll memorize sine rule. Okay, so now we are familiar with addition of vectors. You can check some problems by yourself. In next lecture, we'll see how to multiply vectors. Thanks for watching the lecture.